Okay, so I've got two of these American DJ megapixels, and overall I'm pretty happy with them, pretty good lights, but every so often I lose a couple of the LEDs, and it takes out several when one gets shorted. So I'm going to show you real quick. It hasn't happened on any of the green ones yet, but if you look here you can see I've lost a blue one, a few more, half the reds in that section. You can see I'm missing quite a few on this bar by the time you go down the whole line. So I'm going to take this thing apart and show you what needs to be done to fix it up. So right there is the problem. I'm going to crack it open and I'll be back. Alright, so here we got a list of the tools and supplies you'll need. Just got a regular Phillips screwdriver, some solder, a solder iron, a solder sucker, a small wire cutters, a multimeter, and then here we've got the LEDs. Now, like I said, I've never had to replace the green ones, but I do have some green ones here. I bought these off Amazon. Here's the info you would need to know. Now, I bought them in packs of 25, and they were $5.99 a pack, which is actually pretty expensive for LEDs, but it's hard to buy a small quantity at a cheap price. So I bought 75 LEDs for $23.10 shipped. So like I said, pretty expensive for LEDs, but at the same time that's not really too much money in pretty much a lifetime supply of these to repair the light. So now that we got that covered, I'm going to continue taking this thing apart. I just pulled off the end cap so far, just some Phillips screws on both ends. So I will be back in a minute. Okay, so I took the two end caps off, and then there's two screw holes about in the center, and they go to a small bracket that sits right inside here. And once you remove those two screws, then you are able to just slide the whole casing right off either end of the whole light bar. So I've slid that off. Now the next step is going to be, and of course I've done all this with it unplugged, the next step is going to be to take off these Phillips screws. Let's see, I don't know exactly how many, but you can see there's these standoffs all the way down. So we're going to take all those Phillips screws off, and then we're able to actually pop the board out where we can start testing for the bad LEDs. One thing I didn't point out, you can see here I ordered this August 16th of 2011. Obviously, I've been at this for a while, so this is nothing new here. I just picked out some general LEDs. I don't know specifically what is used in this, but I believe these are pretty generic LED that are used in this. The ones I got, and if you can see here, let's see. There we go. If you see right there in the center of the screen, that's one that I've replaced before. It doesn't match up exactly the same. The case of it's round instead of an oval, but for all practical purposes, you can't tell the difference once it's all lit up and everything. Nobody will ever know. You really gotta eyeball it to even pick it out. So anyways, we've got the board loose here. So now what I'm going to do is I'm going to power it up, and then we can actually test. That's the easiest way, in my opinion, to do this. We can test for voltage drop across the LEDs, so we can pick out exactly which ones are shorted out and have the massive voltage drop across them. So that's going to be our next step. This one right here, I'm actually seeing somewhere between, it's ranging a little bit, but it's somewhere between 10 and 13 volts. So that one is our bad one. So what I'm going to do here is I'm going to mark it with a Sharpie. I'm just going to put a mark right on the face of it, and I'm going to continue down the line because we got a bad one here and we got a bad one there. Okay, so I'm back here, so kind of tough to tell, but if you look close you can see I've just marked the bad ones with a Sharpie, so I can come back. Definitely hard to see with the glare there, but so I can come back and swap those out and know which ones are bad. Now on this circuit you can see those, the rest of them are dimly lit. On this circuit and this circuit, they are dead shorts, so that none of the LEDs in the circuit are working, even though only one's bad. And the ones that I've marked that tested bad, they actually basically had a dead short across them, and they were reading about 15.5 volts, and the other LEDs in the circuit weren't reading anything. So either way, the one with the big voltage drop, that's your bad one. So now I'm going to turn this thing off, unplug it, the circuit board from the light itself, and then fire up the solder iron and swap these things out. Alright, now I actually tested the red ones as well, because it turned out I had one red one that was out, that guy right there, and you can see on the board it actually says whether it's blue, red, or green, so it's pretty tough to screw this up. You can also see the drawing on the board, there's a flat side to it. If you look close at the LED, there's a flat side on the LED as well. So you just want to make sure that you line that flat side up. So we're going to swap out the red one as well as all the blue ones we found that need to get swapped out. So just make sure you match the colors up right and make sure that you match the flat side up, because the polarity does matter. And also I would only recommend taking one color out of the bag at a time, because once you've pulled it out of the bag you can't tell what color it is anymore. Alright, so we've got a blue LED that's bad right here that I marked. So I'm going to flip it over and we're going to heat up the solder. Sometimes it's good to add a little bit of fresh solder on there. So we're going to heat it up, use a solder sucker on it, do the same thing on the second lead. And if you did a good job, you should be able to move the LED back and forth and break it free. If it doesn't come free, don't force it, or you'll pull a trace out of the board. That one came out nice. So we're going to grab the new one, make sure we line the flat side up, make sure you got the blue LED in there. We're going to put it in, and just like they did from the factory, we're going to bend the leads over slightly to hold it in place. Get some new solder over here. Just put enough on each lead. Make sure it flows good. And there you go. Now we're just going to clip off the excess leads. And there is how you replace the LED. So I'm going to repeat that on the other bad ones I've marked, and then we're going to put it back in and test it. Alright, so I've got it back together, powered up again. The one thing, and I don't know if you're going to be able to see this on the video or not, right there is the new LED in that particular circuit. The beam angle isn't as broad as the factory LEDs, so if you really wanted to get into it and find out what they used, you could match it perfectly. However, with the way these things have been going out on me, I think you probably may as well just use whatever you want, because you probably got as good of a shot. You can sort of tell those two LEDs right there are also ones I've now replaced two in that circuit. So they look slightly different. I think there's a pretty good shot of how the beam is more direct on the ones I'm using. But now we've got all the circuits working again on this half. So now we're going to move over to the other half here, where you can see I've got several red and blue ones to deal with over there. But basically that is how it goes, and then, you know, slap it back together again and you're good. I've got two of these lights, so I'm a quarter of the way done. But when it's all said and done, really not that difficult. Alright, so I've got it all back together again now, or mostly anyways. Put the main housing back over it. As you can see, all of them are lit up just like they're supposed to be. Now, one thing I should mention, and I should have probably mentioned earlier, but when I'm dealing with this thing and testing it live, you want to treat it like it's live. There's pretty low voltage going to the actual LEDs on the boards you're pulling out, but either way, it's, you know, exercise the appropriate safety cautions when doing it, because there is, even though it's low voltage, there still is voltage there. So be very careful when you're dealing with it, and power it off and unplug it as soon as you're done doing the testing, so that you eliminate any chance of hurting yourself or anyone else while doing the project. So now what I didn't do last time around that I'm going to do this time, I'm actually going to skip putting these screws in and this bracket that goes in the center. In the past, what I did is I took this whole back housing off to get in there and do it. I think I'm going to skip it this time. I'm sure that it helps reinforce and hold together the center section, but for the way I use these things, they don't have a very rough life, and I don't think there's really going to be a downside to that. And it makes it a lot easier putting it back together again. Like I said, I just literally slid the whole lens and side pieces right back on, and now I can put the end caps on and call it a day. So I'm done with this one. Gonna grab the second one here and finish that off, but I think that's pretty much all you need to know to get these megapixels repaired. Okay, so I've got the second light out here now, and there's really no reason to go over anything on this one since I covered it on the first one, but just thought I'd show you. I got a bunch of reds, got a whole panel of reds out, half of a blue one there, part of a blue one, part of a red one, part of a blue one, part of a red one. So this thing definitely is going to require a little bit of work as well. Hopefully you found this helpful, and let me know if you got any comments. Good luck with the repair.